Section 5.3 exercises. Problem 1. We are given the coordinates of point P on the terminal side of the angle theta. Find each of the 6 trigonometric functions of theta. Well, first we'll plot that point and get a reference for where we are located. Point P is at 1, -3, so to the right 1, down -3. And our angle then is this angle here. That sets up our triangle, our right triangle there in quadrant 4, where the x length here is 1 and the y length, well, is 3, but it's -3 since we're in quadrant 4. What that leaves for us is to find r, the hypotenuse. So we will do that. R is the square root of x squared plus y squared, so 1 squared plus -3 squared. And 1 squared is 1 and -3 squared is 9, so that'll give us the square root of 1 plus 9, or the square root of 10 for r. Once we have that, we can get our 6 trig functions. The sine of the angle is equal to the y over the r. Y is -3, r is root 10. We then multiply by root 10 over root 10 to rationalize, giving us -3 root 10 over 10. And then we get the cosine value. Cosine of the angle is the x divided by the r. So 1 over root 10. Rationalized then is root 10 divided by 10. And we get the tangent. Tangent of the angle is the y over the x, so that is -3 over 1, or -3. Now we get the remaining 3 trig functions for free. The cosecant of the angle is the reciprocal of the sine, or you could use hypotenuse over opposite. That would work too. I would reciprocate this one here, and then we don't need to re-rationalize, and that'll give us root 10 over -3. And then the secant is the reciprocal of the cosine, or you could use r over x. So that is reciprocating this value here to give us root 10. And then the cotangent is the reciprocal of the tangent. Reciprocating -3 gives us -1/3. And we move on to problem number 2. Evaluate, if possible, the cosecant of 180 degrees. Notice I always draw the picture to get a sense of the given angle. There it is, 180 degrees. That's a quadrantal angle. That puts us there at pi radians, which is 180 degrees. And the coordinates there in the unit circle are -1, 0. The -1 is the radius of that unit circle. To find the cosecant of 180 degrees, or at pi radians, cosecant is the reciprocal of the y value. So we go to our coordinate there at -1, 0, and we put in the y value of 0, and division by 0 is not defined, so it's not possible to find the cosecant of 180 degrees. Not defined. So there's no value that we can write down that will answer the given question. Problem 3. Find the quadrant in which the angle lies if we're given that the sine value is negative and the cosine value is also negative. Always think with sine, the y coordinate. It's the y over the r, but the r is the radius of the circle, which is always positive. So just think sine is the y coordinate and cosine is the x coordinate. And now think, where is the y coordinate negative and also the x coordinate negative? Which quadrant would that be? In the third quadrant, both y and x are negative. So it must be quadrant number 3 is where the angle would be located to have a sine and cosine that are both negative. Problem number 4. Given the tangent to be -1/3 and the fact that the cosine is less than 0, we want to find the sine and the secant of the angle. Okay, first we have to figure out the quadrant that we are in. If the cosine of the angle is less than 0, and we always think x coordinate for cosine, that would mean that we're either in quadrant 2 or quadrant 3. Quadrant 2 or 3. That's where the x-coordinate is negative. And the tangent is also given to be negative. So if the tangent is negative, then we must be, let's see, tangent is y over x. So where is that ratio negative? That would either be in quadrant 2 or 4. Quadrant 2 or 4. So where these two angles would overlap would be here in quadrant 2. So putting this information together says our given angle is in quadrant number 2. So now we know where it is. So we will now draw our picture. We're in quadrant number 2. So there's our angle there, theta, sweeping us to quadrant number 2. And there is our right triangle in the second quadrant. And the tangent value is negative 1/3, and that is y over x. So the x must be the negative value, and the y must be the positive value. So let's check that. Tangent is opposite y over adjacent x, and 1 over negative 3 is what is given. Okay, to find the sine and the secant, well, we're going to need to get the value of r there and use the Pythagorean theorem to do that. So we'll squeeze it in right here. R is the square root of x squared plus y squared. And that should look familiar. We get root 10 again, as we did in a previous problem. So now we'll get the value of the sine. The sine of the angle is the opposite length 1 divided by the hypotenuse root 10. So that will give us a sine value of root 10 over 10. And then we need to also get the secant. The secant of the angle is the hypotenuse divided by the adjacent. So that'll be root 10 over negative 3, or negative root 10 divided by 3. And that'll be the value of the secant. Problem number 5. Find the reference angle for an angle measuring 7 pi over 4 radians. Okay, first we have to think 7 pi over 4, we can write it as 7/4 pi. Thinking about that as a mixed number, 7/4 is 1 3/4. So 1 3/4 pi, or in other words, 1 pi, 180 degrees, plus 3/4 of pi, 3/4 of 180 degrees. And this will help us find the quadrant in which we are working. So here is your 1 pi and 3/4 of pi. Pi is a full 180. That's halfway to 180. We want 3/4. So that's going to put us over here in the 4th quadrant, and that'll be where our given angle theta lies. Okay? Our reference angle, here is our right triangle. Our reference angle is always the acute angle here pinched between the terminal side of the angle and the x-axis. So the reference angle here will be, we can take 2 pi, let's see, so all the way around, and then subtracting our given angle, all the way around, subtract our given angle, we'll leave this little amount here, which is our reference angle. So 2 pi minus 7 pi over 4, finding a common denominator, writing this as 8 pi over 4 minus 7 pi over 4, leaves us with our reference angle, pi over 4. And that's the reference angle for the given measure of 7 pi over 4. The easy way to think about this is 2 pi is 8 pi over 4. So if you've already gone 7 pi over 4, then you need one more pi over 4 to reach 8 pi over 4, and that's your given reference angle, and you can get around the math that way. Let's take a look at problem number 6. Find the reference angle for theta equals negative 240 degrees. Okay, more familiar to work in degrees. I'll still draw the picture. It's a negative angle, so we'll be rotating in the negative direction. So starting on the positive x-axis, rotating this way. There's 180, and we need to go a little bit more here to get to 240 degrees. So there's negative 240 degrees. Draw your right triangle associated with that quadrant. There we go. And the reference angle, as always, is pinched in right here between the positive x-axis and the terminal side of the angle. What we'll do is take our given angle of negative 240 degrees and we'll add a full rotation of 360 degrees. This will then give us our coterminal angle, which is this one right here. That's a positive rotation. So if we do that, we'll have 120 degrees. So rotating from the positive x-axis this way, negative 240, is the same thing as starting on the positive x-axis and rotating to the second quadrant in the exact same place, but this is a positive angle of 120 degrees. Our reference angle is still in the same spot as it was before, but now it's very easy to see. If you've already rotated through a 120 degree rotation and you know halfway is 180, how much more here do you have left? And that would be 60 degrees. So your reference angle is 60 degrees. If you want to see the math, then that would be 180 minus the given angle of 120. And that's still a different way to show the reference angle. Okay. Let's do it again for a different angle, negative 11 pi over 3. Okay, so we'll set up a picture here. Negative 11 pi over 3. Well, 11 thirds is 3 2/3. So 11 thirds pi is 3 2/3 pi. 11 pi over 3 is 3 2/3 pi. So that's 3 pi plus 2/3 pi. But negative. All of this is negative. So we have to start on the positive x-axis, and we'll rotate 1 pi, and then 2 pi, and then 3 pi, and a little bit more. 2/3 of a half rotation. So by doing that, we'll end up here in the first quadrant. 2/3 of the way to 180 degree rotation. So there's the given angle. We'll now find the coterminal angle as we did before. So we'll take negative 11 thirds pi and we'll add 4 pi to it. Why 4 pi? Because adding 2 pi will still make the given angle negative since it exceeded 3 pi. It's 3 pi plus more. So we're going to have to add enough to make it a positive angle, and that will be adding 2 full rotations to it. So finding a common denominator there, 11 thirds pi plus 12 pi over 3 gives us our coterminal angle of pi over 3. Now what's nice about this is pi over 3 is our coterminal angle, but that's also this angle here in the first quadrant, which is our reference angle. So in this case, our coterminal angle happens to also be our reference angle, and that happens anytime you're in quadrant 1. If you're not in quadrant 1, you have to then proceed to the next step to find the reference angle. Problem number 8. Let's get the exact value of the sine of 300 degrees, and we'll need a reference angle to do that. So, as always, I'm going to draw a picture first. So, positive rotation, there's 270, all the way over to there, 300 degrees, there's your given angle. That sets up your right triangle right there. And your reference angle is always pinched between the x-axis and the terminal side of the angle. Very easy here, since we're in degrees. If you've already moved through a rotation of 300 degrees and a whole circle is 360, this amount here would be the remaining amount you would have to rotate. So that would be 60 degrees for the reference angle. Okay, so 60 degrees reference angle, we use our special right triangle here. So it's this triangle drawn here off to the side. And we have 60, 30, 90 triangle. And with the lengths of the sides, hypotenuse is always 2, and the 1 is opposite the 30, and the square root 3 is opposite the 60. They have to focus that we're in quadrant 3 here, and the x length is always positive since we're in quadrant 4, and the y length is always negative. So this is negative root 3 because of the quadrant we're in. Now we can proceed to get the sine of 300 degrees, the y value over the r, or the hypotenuse. Y is negative root 3, and r, the radius of the circle, the hypotenuse length is 2. So negative root 3 over 2 would be the value of sine 300 degrees. Okay. Hey, let's do it again. Reference angle needed to find the exact value of tangent 5 pi over 4. So as always, where is 5 pi over 4? If you don't know where you are, you can't get these trig values. 5/4 pi is 1 1/4 pi. So that's a full 180 rotation and then a quarter of that. And this helps to figure out how to locate your angle. So full pi plus exactly 1/4. Right there. There is 5 pi over 4, and there is your resulting right triangle. Your reference angle is always right in here. This is somewhat easy to see. If you've already undergone a rotation of pi, then this reference angle here is the amount by which you rotated past the 180 degree or pi rotation. And that's this part right here, 1/4 pi. So a reference is 1/4 pi or pi over 4. Okay, I'm now going to draw my triangle. Notice I'm orientating the triangle in the same way it appears in the quadrant that I'm in. This is our 45, 45, 90 with length of sides 1, 1, root 2. But always mind where you are. In this quadrant 3, the x length is negative and the y length is also negative. So we have to put the negative signs on there to indicate the quadrant we're in. Now we can get the value of tangent 5 pi over 4, which is the y length over the x length. So the y length is -1 and the x length is -1, giving us +1 for the tangent of 5 pi over 4. One more time, secant of -pi over 6. Okay, draw the picture. Negative rotation by pi over 6 is a small rotation this way minus pi over 6. So that'll give us our right triangle there in the 4th quadrant. Now the reference angle in quadrant 4 is always between the terminal side of the angle and the positive x-axis. It's this amount right here. We could go get the positive coterminal angle this way, but measuring -pi over 6 in this direction is the same as measuring +pi over 6 sweeping in that direction. So the reference angle here is +pi over 6. Okay, so now let's set up our triangle, orientated in the same way as it appears in the quadrant. This is pi over 6, that's 30 degrees, so we'll have our 30, 60, 90 right triangle. Length of sides, 2 for the hypotenuse, 1 here, and root 3 here. Now adjust for the quadrant. X is positive, so we keep that to be plus root 3. The y is negative, so that's a -1. Now we can get the secant. So the secant of -pi over 6 will be the hypotenuse length r over x. R is 2, and x is root 3. To rationalize that, multiplying by root 3 over root 3 will give us 2 root 3 over 3, and that's our value of secant. I'm not going to get that in there. That's secant -pi over 6. And that's the conclusion of section 5.3 exercises.